Around 66 million years ago, the Earth experienced a mind-blowing extinction event that completely rocked the planet, no pun intended. An ultimate game of survival where entire classes of species were wiped off the face of the planet, and those who remained had to undergo extreme makeovers to adapt to the new conditions. So, what caused this massive extinction? The exact reasons for this massive event are still a bit of a mystery, but there's no denying that the Cretaceous-Paleogene extinction made some pretty significant changes to the Earth's appearance. It was like a before and after photo, where the majestic and terrifying dinosaurs were eventually replaced by equally impressive but much more cuddly creatures, mammals. The numbers are staggering. 3/4 of all living organisms on Earth were wiped out. Almost all creatures heavier than 25 kilos ceased to be. To put it into perspective, that's the same weight as an average goat these days. Basically all dinosaurs that couldn't fly. It was like the ultimate purge, marking the end of the Mesozoic era and the beginning of the Cenozoic era, which is still going strong today. Can you imagine what the world would look like today if the Cretaceous-Paleogene extinction event never happened? Get ready to take a trip back in time to the Paleogene era, the first and longest geological epoch that lasted an incredible 43 million years. But where there's tragedy, there's opportunity, and the vacant ecological niches were quickly snatched up by the new masters of the planet, mammals. Interestingly, the Paleogene era is often compared to the modern-day world in terms of its geography and biodiversity. The Earth was warmer than it is now, and the poles were free of ice. The vegetation was also very different, with forests covering much of the land. This raises the question, could we be heading towards another Paleogene-like era with the current changes in climate and biodiversity? It wasn't just the fauna that was different back then. The geography of Earth was also all over the place, like a giant game of Tetris gone wrong. North and South America were separated by a shallow sea, like two neighbors who just couldn't get along, and the Indian subcontinent was just starting to peek over the ocean's surface. The Tethys, a prehistoric ocean, still lay between Africa and Eurasia, but it was starting to disappear due to the movement of tectonic plates. Despite the differences, one thing was clear. The climate of the Paleogene era was a lot warmer and more stable than today. This is a stark contrast to the climate we experience today, which is characterized by extreme weather events and erratic temperature fluctuations. Think about it. When was the last time you saw snow in Egypt? The planet was covered in dense and lush tropical forests, providing an abundance of vegetation for the vast array of living creatures, most of which were quite small. This lush landscape allowed them to propagate quickly and spread across new areas. Among them were the miacids, a small but cunning predator that roamed the warm forest of the Paleogene era. And let's not forget the archaeocetes, who were just starting to take their first steps towards the sea. Although they looked more like hippos at the time, their limbs and respiratory organs were already adapting to prolonged stays underwater. The archaeocetes did not have the benefit of observing and learning from other aquatic animals. Our next stop in our journey is the Eocene epoch, a time where our planet was still figuring out its identity. The Eocene began about 56 million years ago and lasted for over 22 million years. But then the continents were taking shape, and India was finally done with its journey to the southern shores of Asia. The collision of tectonic plates was so intense that it created giant rock folds that birthed the Himalayas, the largest mountain range we know today. Some of the species from that time might look familiar, while others were a whole new breed. Let's take Andrewsarchus for example. This guy was one of the largest mammal predators ever to roam the Earth. His skull measured a whopping 84 centimeters, which is 1.5 times bigger than that of a brown bear. Its bite was also harder than any land predator we have today. With deep tooth sockets and strong mandible muscles, this beast was built to crush its prey. Its skeleton measured over 4 meters in length and weighed as much as a ton. Studies show that Andrew was an omnivore and wasn't picky about eating carrion. Hey, we all have our guilty pleasures, right? Regrettably, the enigmatic nature of this captivating creature persists as scientists grapple with its organism structure, behaviors, and relation to other mammalian families. The Oligocene period, which marked the end of the Paleogene, spanned around 11 million years, commencing approximately 33.9 million years ago and ending 23 million years ago. This epoch saw a global cooling trend, with tropical forests giving way to vast grasslands, and the Antarctic glaciation rendering the once lush continent desolate. Meanwhile, tectonic plates shifted, mountains formed. For instance, the Alps, about 26 to 28 million years ago, and the supervolcano Margarita erupted from such ferocity that life within a massive radius was obliterated by being buried under layers of hot ash, as much as 100 meters thick. While the global cooling trend and geological events like the formation of the Alps and the eruption of the Margarita supervolcano had significant impacts on the planet, it's also worth noting that some things have remained relatively constant over time. For example, the basic structure of living organisms and the fundamental laws of physics and chemistry that govern the natural world have not changed, even as the Earth has undergone dramatic transformations. Could there be an event so drastic that it could change the chemical structure of living things? Despite these cataclysmic events, life persevered, and fascinating creatures roamed the Earth. Some of these creatures were as massive as dinosaurs, such as the Indricotherium, a herbivore related to rhinos. With a shoulder height of 4.8 meters, this giant was even taller than a large African elephant. Its remarkable long neck allowed it to reach heights of up to 7 meters, and with a weight of up to 20 tons, it was the largest land mammal of all time. Interestingly, the Indricotherium's height of 4.8 meters and its incredible reach is comparable to the height of a 2-story building. Although not a single complete skeleton of this magnificent animal has been found, fragments suggest that it did not have a massive horn like its rhino relatives. Instead, it may have had a small trunk-like nose, similar to today's tapirs, to reach and consume leaves from treetops. These behemoths likely traveled in small herds across vast expanses of land, searching for food. Sadly, the Indricotherium, with its impressive size and long neck, is now extinct. It was a period when prehistoric elephants and large predators roamed the areas that herbivore giants used to inhabit. The emergence of new large herbivores disrupted the balance of nature, leading to fierce competition for food and threats from the new dwellers, which ultimately led to the Indricotherium's complete extinction. Today's ecosystems are also vulnerable to disruptions caused by human activities, such as deforestation, pollution, and climate change, which can lead to the extinction of many species. What will the future hold for us humans? The truth is, we cannot predict what the future holds. The future is uncertain, and it's up to us to determine our fate.